We have, if you start with the Teradata database, it's nothing but it's an RDBMS, just like any other RDBMS, like Oracle, SQL Server, Microsoft SQL, like that. It's an RDBMS. And Teradata, it has been designed to run world's largest commercial databases. It has been a preferred solution for enterprise-wide data warehousing. It's mostly for an data warehousing perspective, not for a transactional system perspective, like OLTP. It's not an ODS or operational data server. It's an analytical data platform, ADP we can say, for enterprise data warehousing, where the data, where the information gets captured from multiple source systems, the OLTP, and then resides in the warehouse. It is that kind of a system. It's a warehouse. And it's an open system. Why we say it's an open system is it can run on multiple platforms like Unix, MPRAS, Linux, and Windows operating system. And it's compliant with the ANSI industry standards. Like whatever the SQLs or the semantics it follows, it follows all the ANSI standards.
How many rules does it comply with? Further?
I didn't get you your question.
How many ANSI rules does Teradata comply with?
How many? I'm not sure actually on the count, but the semantics are completely ANSI standards.
Okay.
Maybe more than 95%.
Okay.
And it's compliant. Yeah, it runs on a single or multiple node. I will explain you in the coming slides what's a single node or a multiple node means.
Okay.
And basically it's a Teradata database server where uses a parallelism concept to manage terabytes of data. And it is capable of supporting multiple clients from various, many concurrent users from various client platforms using the massive parallel processing architecture. We say Teradata architecture as an MPP architecture. That's nothing but massive parallel processing architecture. It can process terabytes of data using parallel processing mechanism. And if you look,
what is processing?
Processing is like to process the data.
Okay. Process a particular task.
Yeah, processing a task, performing a task.
Okay.
And if you come to the history of Teradata, it has been started way back in 1975. And in 1979 they released their first product. And the major, like if you see the big major releases, right, in 2002 V2R5 was released. They started with V1R1, V1R2, V2R1, V2R2. Right? And these are the features which we are familiar with actually, like V2R5, which released in 2002 and 5.1 in 2003. And if you look at the release, right, there are some major features actually which included in that particular release, like including of.
What does it they mean? PPI.
UDF is a user-defined function. Like you can write your own function and embed it in a SQL.
Okay.
You can write a PPI is partition index. Why we partition the data, that kind of stuff.
Oh, that's what I just talked about. Okay.
Yeah. And, blobs and globs, like handling large binary objects or large character large objects like that.
Mm-hmm.
And V2R6 in 2005 was released, and collect statistics was the feature which got enhanced in that release. And in 2007, 2009, query rewrite and scalar subquery features were getting embedded in TD12 and TD13. TD14 it's already released to the customer, the beta version, and in 2013, in the first quarter, full version will be released with all the features, a customized customer version. So currently the market is running on these three releases, TD12, TD13 and TD14. So if you are onto a job, then you will be onto any of these three domains. You will be either working on TD12, TD13 or TD14. And the difference from version to version will be very minimal from the user perspective. As a user, you will not be able to see much difference actually. Only the difference will be there is from the system perspective. Very few features will be there where you need to have a knowledge of little bit syntax on that particular feature, but rest all is same. How you write a SQL either in TD12, TD13 or TD14, it's well and the same, one and the same. That's what it. TD14 temporal feature and columnar feature has been added. Columnar feature is nothing but it's we generally assume a database to be in the form of a rows, right? Rows. Each record is in the form of a rows. But from and even if we do partition, right? We do partition like a set of data, a set of rows into one partition, a set of rows into one partition. But columnar feature is a different partitioning actually. We partition the table from column perspective. Employee name, single column. We partition that particular column as a separate set. Employee number, salary. We partition that into a separate column. That kind of feature. We can do horizontal or vertical partitioning. Horizontal is already there, but vertical partitioning of a table, that is possible using columnar feature. Few advantages are there with that particular feature, like the competitive is Vertica, a Vertica database, which is column oriented, columnar. We say it's a columnar database. That is the competitor for Teradata on that particular feature. So once we finish the class, like if I have the, I can give you an overview of that particular feature, temporal as well as columnar. Then if you look at the architecture, right, this is the basic architecture of the Teradata. And if you look at a gray color box, right, this we can consider it as a node, a single node system. In the earlier slide, I said, right, Teradata runs on a single node or a multiple node. This is a single node. If I say multiple node, then these kind of nodes, multiple times, n number of nodes I can have, where n is maximum of 1K or 4K. Less than 4K it can be. That those many number of nodes I can have as my system. And the major components in a particular single node is, and coming to the
the question was, you said this is a single node.
Yes.
A node consists of the parsing engine,
message passing layer.
Message parsing layer is what, the BiTech?
Binet.
Binet. And amps, I understand, and those are the physical disks.
VDisk. We say it's a VDisk, virtual disk.
Virtual disks. Yeah, virtual disks are actually in the same disk, they are partitions, right?
Collection of physical disks, we say virtual disks.
Virtual disk. So this I understand. Now what you said was, this is one node. You can have multiple nodes on one system.
Yes, multiple nodes as a system.
As a system. So these multiple nodes are they in one data warehouse, or
yeah, they act as a single data warehouse. They act as a single data warehouse.
Okay. So it could be on too many on multiple computers too.
That's what. If in my system I am installing TD12 version, so this will become a single system. Similarly, if I install one more Teradata 12 version on another system, then they become two independent systems. But using an external Binet, I can connect these two systems and configure it in such a way that they act as a single system.
Okay, I got it.
That is an MPP architecture. So
MPP.
This is one node, MPP, massive parallel processor architecture.
Okay.
That's what. Now collectively, these two nodes will act as a single system, not one system. Collectively, those two nodes will be acting as a single system. And parsing engine, it does the syntax and the semantics request processing. And whatever the request you send to the RDBMS, it will check for the syntax and then semantics, and then do further optimizations if it can do.
I understand syntax. What is semantics?
Semantics is nothing but whether the rules are being properly defined in your query. Like if you give a select sum of salary, comma, employment number from EMP, then from the syntax perspective, then we need to give a group by clause. That is the syntax checking actually. Then the semantics is nothing but whether each and every component is there in your particular system or not, resolving kind of stuff. From the syntax perspective, it is true, but the object might not be there in this in your particular database. Then it will throw an error. Like you can create a view with the SQL which I have said. You can create a view like that, but that will not throw you any.
Isn't that called a syntax error?
No. 1 second, just give me. I will show you. What I said was select sum of salary, comma, employment number from EMP. I will create a view actually. Create view V1 as this one. This query will execute.
Yeah.
But there is some flaw in it. What is the flaw? Group by one. When you execute it, it will throw you an error. That is the semantics.
So the error is the error is not highlighted while you're writing the query on the SQL assistant.
Yes, this will execute. That's what I'm saying. That's what. From syntax perspective, it says that this is true.
Okay.
Because everything is in place. After select clause, there is a sum of salary clause, an expression. Then after that, a comma is there. That is fine. Then after that, I have an expression. That is true. Then I have a from clause. That is true. Then I have an table name. That is true. From the syntax perspective, it is true. But from the semantics, it expects a group by. That is the semantics. So those things are done in parsing engine, and it has even one more component called hashing algorithm, where it can distribute the data across multiple disks. You have a table of 100 million records. That hashing algorithm has the knowledge how to distribute your data across your disks, or across the AMPs, I can say. How that happens, what is the logic behind that, like what are the parameters it takes, we will be seeing when we discuss the data storage and data retrieval class. And coming to the message passing layer, it's a communication protocol between passing engine and access module processor, which we say. It can do point-to-point communication, multicast communication, and broadcast communication. Multicast is nothing but a group of AMPs. It can send the request to group of AMPs, or it can send the request to a single AMP, or it can send the request to all AMPs. Those kind of communication it can do. It can even handle the result set which has been fetched from the AMP to the passing engine. Like once the AMP finishes processing the task on a table, it gets some set of results. Those results will be passed to the message passing layer, and message passing layer gets the results from various AMPs. Then it has the knowledge to club all them as a single set and then send it to the client, then send it to the passing engine. And each AMP is responsible for handling vdisk associated to it. So here in this example, a client is trying to insert data like around 12 records into a single table. He wants to insert 12 records into a single table, and this is how the distribution has happened. It distributed record 2 to first AMP, record 12 to second AMP, record 80 to third AMP, record 25 to fourth AMP, like so on. So it has 12 records, and it has distributed the records in this fashion. So a single table data will be divided across the AMPs in your system.
So that question.
Yeah.
Does this happen even without a fallback condition in your
Yes.
fallback? Where there's no fallback condition in your create or insert query?
Yes, yes. Even when we create a table without any fallback also this happens.
Okay. So this is a default default um, what should I say, default
Yeah. Whatever data you have, it will try to distribute the data across the arms in your system.
so that's a
We'll go
default.
into a little bit. Yeah. We'll go into the details like how it is able to distribute. Will there be any skewness? What are the criteria for getting an even distribution? Those kind of stuff we will be learning in the data storage and retrieval part class. And once this is done, if you send a request to this particular table, like select star from T, where T is a table, then what happens is passing engine will scan the request for syntax and semantics errors. Once everything is fine, it will send the request to message passing layer and then broadcast it to all the amps. So each amp will be having now a request like select star from T. So each amp will be processing that request on the VDISK, associated VDISK. So we are dividing a single task into multiple tasks, and multiple tasks are performing parallelly on the amp. So each amp is processing the same task parallelly. And once each amp finishes the task, the result set will be passed to the message passing layer. Message passing layer will club the results into one single set and then send it to the passing engine. And from passing engine to the client, from where the request has been received. So this way a parallelism is possible in Teradata. We divide a single task into multiple tasks, and multiple tasks perform in a parallel fashion across a So what are the limitations, like how many number of parsing engines it can have, how many number of amps it can have? Those are configured from each and every node perspective, and there are certain limitations that I will discuss in the next class. Like what's the configuration of a system? How many number of parsing engines can I have in a single node? When I say single node, how many number of amps I can have? Like 128 is a maximum. I can have 128 processing vprocs actually. Either it can be a parsing engine or amp. 128 is the maximum limit for a node. I can't have more than that. That's the limitation. Any questions here on this slide?
No. I didn't expect that you would ask this question. Any questions? I actually had some question in between. You said, what is that? Okay, anyway, it's gone. Next time I'll write it down when I get the question.
Yeah, sure. You can stop me in between if you have any questions. Actually, then I will itself.
So when the classes begin, does that construction stop?
I will make sure that now are you able to hear it, because it is going on still. But are you able to hear now?
Is it the classes are usually on weekdays, or like weekdays for us here?
Yeah, actually Teja Dharma's the person, he said that you are looking for a weekend class, right?
Yeah, I preferably that would be
Fine, then I will inform him, and the time slots actually when we can have even on the weekend.
The weekend does not suit me.
Weekdays is a regular batch. Like if few people are there only for weekend, I can take a separate batch for them. That's what I mean.
Oh, okay.
2 batches. I mean to say. You will be not into this batch. Yours will be a separate batch which occurs only on a weekend. That's what you are asking for, right?
Yeah.
Yeah.
I was asking Teja for daytime, our daytime, and Monday through Friday.
Daytime at your...
That will be your evening.
No, that is not possible actually.
Yeah,
Because I will be reaching around 10, 11 o'clock at the night. So it will not be possible for me to take a class at that time. This is the preferable time for me, morning or early morning. And
one more is I would like to get certified.
yeah, I will provide the materials as well, and I will make sure that you clear your certifications.
Okay.
Till now, not even a single person has failed from the certification point of view.
Okay.
I can guarantee you basics as well as SQL.
Yeah.
I wanted to get certified too.
So that's what I will be providing you the materials and help you on the certification front too. No issues on that.
Okay.
Even well-defined materials are also there on that front. You can go through that. Some sample questions as well. So once you're done with that, you will be certified.
That is what
this class. And the terabyte is 1000 GB. Let's say 1000 GB. We say it's a terabyte, 10 power 12 bytes. And these are some of the common differences between Teradata and other RDBMS. But this was a very old comparison, which I haven't removed yet actually. And because most of the other RDBMS like Oracle, it's also coming up with some of the parallelism concept actually. Like recently they have released a product from the data warehouse perspective, Exadata, which they have said that it's comparable and more faster than Teradata RDBMS. But they followed some of the architectural concepts of Teradata, the parallelism concept. So most of the differences might not be suitable right in the current environment, because most of the new RDBMS have evolved. This was a very old comparison, but we will only look from the Teradata RDBMS perspective. Like they have defined it parallelism as unconditional. They haven't restricted parallelism to each and every component. Every component, the parallelism is unconditional, and it has been designed for a decision support system and data warehousing. That was their main intention. They have entered into the market only with that purpose. And we said Teradata architecture is a shared nothing architecture. Shared nothing architecture is nothing but I said that each AMP is responsible for its associated VDISK to process the data in its associated VDISK. This VDISK will never be shared across any other AMP. Even though if it requires the data, this VDISK will be never shared across any other AMPs. If it needs data, then what it do? It makes a local copy of the data with the help of this AMP. That's what it happens. So the data is not shared across the AMPs. That's why we say it's a shared nothing architecture. And it supports terabytes of data as well as billions of rows efficiently to handle. And index usage is common. Why we use indexing is for faster retrieval. That is possible in even in other databases. Apart from that, better storage of data is possible. Better storage of data. We are able to see this distribution, a well distribution of data right across the AMPs. This is because of the primary index. Why we are able to see the distribution of the data across the AMPs is because of the primary index. Based on that, we will be distributing the data. So that's what. In Teradata, index usage is both for faster retrieval as well as for better storage. And from the capacity perspective, yeah, like it can handle billions of rows, process millions of instructions per second. It's the power of Teradata warehouse. And the parallel processing, yeah, it makes the Teradata RDBMS more it's faster than any other relational RDBMS in the real time. It's a single data store, like it can be accessed by network attached clients and channel attached systems. Channel attached systems is nothing but a mainframe client. Mainframe, we say it's a channel attached, and rest all other operating systems like Windows, Linux, if you're accessing through those systems, those clients, we say it's a network attached client using a TCP/IP protocol. And fault tolerance, yeah, Teradata has some automatic detect and recovery from some of the hardware and software failures, it can recover. And data integrity, yeah, this is same in any database. Either a transaction should be complete or should be rolled back to a previous state if any intermediate failure occurs. So that is there in Teradata or any other RDBMS. And scalable growth, yeah, you can allow expansion of your current RDBMS without sacrificing the performance. Like currently, if I have 4 nodes in my business, and if I want to add some additional nodes, then the performance is linearly scalable. There will be not any drastic down in the performance perspective. It is linearly scalable. If I add one more node to my, if I have one node currently, and if I add one more node to my current system, then the configuration is doubled. So my performance is doubled. That's what it is, linearly scalable. And SQL is the structured query language which we use to access the Teradata RDBMS data warehouse. And from the content perspective, have a look. Like we'll be working on Teradata 13. I have even Teradata 14 Linux version. So if you have any questions on that front too, we can even have a go through on that version as well. But this is the standard version which we'll be using for our training. Teradata 13, and basically in initial phase we cover the architecture and other components, and then from the recovery and protection of data perspective, we look at what's a fallback, what's a cluster, what is RAID 1 and RAID 5, those kind of concepts. What are the different types of journals, those things. Then we come into the technical concepts, the different types of indexes we do in Teradata, then the storage and retrieval, how the data gets distributed across the ARMs, those kind of stuff. Then the basic DDL DML stuff for the SQL purpose. Then some basic string functions, aggregate functions, arithmetic operations, those kind of stuff. Then we come into the joins. What are the different joint types and joint strategies, the union stuff, and then the basic commands, then the different types of objects available in Teradata, the tables, views, macros, stored positions, those kind of stuff. Then a little bit from the admin perspective, this one, how to handle the different types of spaces, how to manage a database user, how to grant and revoke access rights, those kind of, a little bit of admin stuff. We'll be starting with these concepts from the practicals. Initially, how to create a database, how to create a user, those kind of stuff. Then we will go into the detail about the indexes, tables, views, macro, those kind of stuff. Then the different types of transaction modes, how we do. Then
BTQ kind of thing.
Yes, batch mode. Then the collect statistics feature, then the explain usage, how we need to understand the explain. Then from the tuning perspective, some best practices, how to write efficiently some SQLs. If I give a requirement, you can write the SQL some 3 to 4 ways, but which is efficient? There will be one query which is more efficient. So what are the best practices we need to follow from the SQL tuning perspective? We'll be learning that. Then we will go into the tools, Teradata utilities and tools, import and export,